So continuation about the motion of an object in the lift, the accelerations. So we have the normal contact force depends on the total downward force if object is there like on the surface. So this object, the first example, the object is on the surface. Okay. And it is the lift is at rest or it may have a constant speed. So if the lift is having lift is at rest or it is moving at a constant speed, the object will not resist the change because it is having the same idea. So in that case, the weight of this person is acting downward, which is 700 Newton, and there is no force to oppose the motion as it is at rest, there is no resultant force. So what about if the contact force here, because the total downward force is 700 Newton. So how much will be the normal contact force? The normal contact will be 700 Newton. That is in the first case. The second example, a person is there in the lift. His weight is 700 Newton. That's the gravitational pull. But now what happened if the lift is accelerating up? So what the body will try to do, the body will try to oppose the change. So how it resists the change? By applying a force, additional force, like example, additional force of 200 Newton. So because of this additional force of 200 Newton, what is the total downward force? The total downward force will be 200 plus 700. The total downward force will be 900 Newton. So what is the normal contact force in this case? The normal contact force will also be 900 Newton. So the total downward force appeared to increase. That's why the normal contact force is also increased. And if the total downward force appeared to increase, if this person was standing on the balance will read higher than what his actual weight is. The third example, a person is in the lift and the lift is accelerating downward. So if the lift, his weight is same, his weight is 700 Newton, which is downward. So normal contact force is a reaction force. It's not originally there. It only produced depending on how much force we applied. So what about the inertia? Because of its inertia, he will try to oppose the change. How it can oppose the change? So example, he apply a force of 100 Newton. Example, it can be any number. So is because of its inertia, he try to oppose the change. So because of this 100 upward and 700, the gravitational pull, the total downward force will be 600 Newton. So if the total downward force is 600 Newton, what will be the normal contact force? The normal contact force will also be 600 Newton. Because the normal contact force is a reaction force, depends on the total downward force. If the total downward force increase, the normal contact force will also increase. And the last example, if a lift is moving same as the acceleration due to gravity and going downward, in that case what happened? In that case, the weight, which is again it's a 700, weight is not changing, apparent weight is there. So his weight is 700 Newton, but because to resist the change, he has a force of 700 Newton because of the inertia. So what will happen? The total downward force will be 0 Newton. So the total upward force will be 0. In that case, there will be no normal contact force. Is it clear? So if you want to write the expression for the normal contact force, here normal contact force is equals to W. Here normal contact force is W plus MA. Here normal contact force is W minus MA. and here the normal contact force is 0. So these are the four possibilities whenever object is moving in the lift. So if the lift is accelerating upward, the object will appear heavier. If a lift is accelerating downward, the object will appear lighter. If a lift is at rest or a constant speed, the object has the same weight, appear as the same weight, but the actual weight will be recorded. Any question or a doubt till this point?
No, sir.
Anyone having a doubt or a question? Inertia is due to the mass and acceleration. Greater the mass, greater the inertia. So as you can see here, when elevator is accelerate upward, the spring scale read a value greater than the weight of the fish. And when it is accelerating downward, it will record a smaller value. So when you accelerate up, you will feel heavier. When you accelerate down, you will feel lighter. So this exercise is related to the Newton's laws of the motion. So what is meant by the Newton's first law? The statements of a Newton's first law. According to Newton's first law, if an object is at rest or moving at a constant speed, if resultant force is 0 or no resultant force, act on it. The next question, identify Newton's third law identifies the pair of the forces. Yeah, object stays at rest or a constant speed unless an unbalanced force act on it. State two ways in which the forces in pair are identical. How the Newton pair forces, Newton third law of forces are identical. They have the same magnitude, same type, acting on the same line of action, acting on the same type of the force. Mean, like example, if one is a gravitational force, the other is also a gravitational. If the other is electromagnetic, like one is electromagnetic, other is also electromagnetic. One is nuclear force, strong nuclear. It's two ways which the pair forces are different. What is the difference? Directions are different and acting on two different objects. So Newton pair forces are always acting on two different objects and the directions are also different. This statement look, one of the student asked a question about a pair force of the weight. The pair force of the weight is not the reaction force. Remember this. What is the pair force of the weight? The pair force of the weight is always the, like example, if our weight, this is one of the student asked a question, so I'll answer. If our weight is 700 Newton, we will pull the earth by a force of 700 Newton. That's a pair force of the weight. What about the force, contact force, when we say the contact force when we are standing? There is a downward force of 700 Newton because of our weight, but there is a downward force. What is the contact force here? The contact force will be 700 Newton. But we don't say that the weight, the pair force of the weight is a normal contact force. That's wrong. We say the contact force, the downward force on the surface, and the normal contact force are the pair forces. So this is the pair force of the downward force, which is due to the weight, but it's not like always equals to weight. It can be more. If I push the ground, my weight is 700 Newton, and I push the ground with a force of 200 Newton. So the normal contact force will be 900 Newton. That's why we don't say the pair force of the weight is a normal contact force. That is wrong. You cannot consider like this. So in this example, one of the forces acting on a car can be described as follows. The earth exerts a downward gravitational force of 12,000 Newton. Describe the pair force. So whenever you talk about the weight, what will be the pair force here? So an object is there which is experiencing a force of 12,000 newtons. So this experience a force of 12,000 Newton, the object will pull the earth by a force of 12,000 Newtons. So why we say acting on two different objects? Because this is a force acting on the object and this is a force acting on the earth. So Newton pair forces, how they are different? They are acting on two different objects. So describe the third law pair force. So what is the third law pair force? It is the force of gravity acting on earth 12,000 Newton on the earth. So the pair force of the weight is always the gravitational force on the earth. Is it clear, this example? Any doubt in this? In this question, the photograph shows a physics teacher carrying out a demonstration, relate the vertical motion. So what he is doing, like example, this is a top view. Like if you look from the side way, this is a table, and he places a coin on the meter rule, and one of the coin is on the table, and when he flip, so this coin will experience a force and it will fall like the trajectory followed by this coin, it will be like this, and the second coin will move downward. It will move downward in this manner. Now a coin A is placed at the top of a smooth ruler. When we use the term smooth, it means we neglect the friction. When he rotates the scale, one of the coin will move downward, hit the ground, another follow a trajectory, projectile path. So one will follow like this, another one which was on the scale will fall downward. So one hand is acting as a pivot, the other hand gives the ruler a sharp horizontal tap, as you can see here. Coin A falls vertically. So if this coin A falls vertically, and both coins are hurt to strike the floor at the same time, and the coin B follow a trajectory like this. But he observed both coins hit the ground at the same time. Use the Newton's first law to explain why coin A has no horizontal motion. Yes, why the coin A? This coin, there is no horizontal motion, it just moved downward towards the ground. What could be the reason for that? So the reason is because the coin A, as they mentioned here in the beginning, the coin A, why it move downward, why not certain distance it cover? The reason is that when the coin A is placed on the scale or a ruler, when this coin A is placed on the scale or a ruler and the teacher moves the ruler, so when the teachers move the ruler, this ruler does not have a friction. As I mentioned here, it's a smooth ruler. So there is no resultant force in the horizontal direction. So if there is no resultant force in the horizontal direction and the weight is balanced with the downward force, because the downward force is due to the weight, but I will use the term downward force. So the downward force by the coin balances with the normal contact force, and there's no friction of the ruler. So if there's no friction of the ruler, so there's no resultant force. If the resultant force is zero, the coin will not move. But then what will happen as he move the scale or a ruler? Now there is no scale. So as a result, what will happen? There is a downward force because of the gravity. There is a downward force. That's why it will accelerate downward, same as the acceleration due to gravity. So the points which you will mention, how you mention the points. So initially, as you can see here, that there is no resultant force, so the coin does not move at all because the upward force, downward force balance the normal contact force, and the coin is not in a state of a motion, so there is no horizontal force. When the scale is moved, the friction is negligible, so there is no horizontal force. The only force which is acting is the weight, which cause a downward acceleration. Why the coin does not move with the scale? Because it's a frictionless, a smooth scale. So the object has a tendency to be in inertia. Like there's a scale, the object is at rest initially. So an object is at rest. What is the inertia? Inertia is a property of an object to resist the change. So when we move the coin, when we move the scale, the coin, because of its inertia, does not move. And when the coin remain there, there is no normal contact force. So only force which is acting is a weight, which cause a downward acceleration. It did not say the acceleration is due to gravity, but why we are considering that? Because when a small distance is there, like a meter or a less than a meter, so we can consider acceleration is due to gravity, as air resistance will be negligible. When a distance is short, acceleration can be considered as same as gravity. Is it clear, this question about the motion of the coin A?
Yes, sir.
Then how this demonstration shows that the independence of the vertical and the horizontal motion means one of the coin just move vertically, the other coin moves horizontally and follow a trajectory of the projectile. But as I mentioned, both hit the ground at the same time, both hit the surface or the ground at the same time. So how it shows that the horizontal and vertical motions are independent of each other? So how we write a structure answer for this will mention for coin A only vertical component of the velocity, but coin B the horizontal velocity is there as well, and initially the vertical velocity is zero. For coin A the vertical velocity is also zero. The vertical velocity component of the coin A and coin B, they have the same acceleration due to gravity. That's why they will hit the ground at the same time. So even though the coin B is having a horizontal component, but the horizontal and vertical are independent. How we show that? Because both coins A and B hit the ground at the same time. And we did the same thing in a projectile questions, that whenever if you drop two objects, one follow a trajectory of a projectile and another one fall freely without air resistance, both will hit the ground at the same time, irrespective of the horizontal velocity. So the vertical velocity of A and B are the same, and B is having a horizontal velocity which does not affect the vertical velocity. That's why they hit the ground at the same time. Is it clear? Any doubt in this? Okay, these are some questions from Newton's law. We'll continue this.